Okay, let's go over how to draw. This is problem B in the Monday, September 9th folder. So we'll go over how to draw the orbital picture for HCN, which is hydrogen cyanide. So the first thing that we need to do is we need to assign the hybridizations of the carbon and the nitrogen atom. So if we're looking at carbon, carbon has two single bonds, two sigma bonds, no lone pairs, so it's going to be sp hybridized. For the nitrogen, it's got one lone pair and one sigma bond, so it's also going to be sp hybridized. So now what I'm going to do is I'm now going to sketch out an sp hybridized carbon and an sp hybridized nitrogen that are going to bond together. So for the carbon, the idea that it's sp hybridized means that it has two hybrid sp hybrid orbitals, and then it has one p orbital up and down and a second p orbital in sort of the z-axis. So these are two p orbitals, and remember that each p orbital has two lobes. And for the nitrogen, I'm going to draw the same thing. I'm going to have two hybrid orbitals, two sp hybrid orbitals, and then a p orbital and a second p orbital. Okay. So as I'm looking at this structure, what I'm going to do is I'm going to have a hydrogen over here that's going to overlap to form the sp sigma bond. And for the nitrogen, the lone pairs are going to be in the sp hybrid orbital. Then for carbon, each one of these orbitals is going to have one electron in it, and for the nitrogen, each orbital is going to have one electron in it as well. So what I'm kind of doing here is saying for the carbon we have 1, 2, 3, 4 hybrid or valence electrons. For nitrogen we have 5 valence electrons. I'm going to go ahead and bond that, and then I'm going to bond the carbon to the hydrogen. So now what I have is I have one unpaired electron, or two unpaired electrons in carbon and nitrogen. So what I would then do is I would overlap the two vertical p orbitals. They're one electron each to form the first pi bond. And then the second pi bond, which is in and out of the plane for both the nitrogen and the carbon, I'm going to overlap those to form the second pi bond. And each one of those p orbitals would have one unpaired electron. So then that's how the orbital picture for HCN would be. You would have two pi bonds, one sigma bond between the carbon and the nitrogen. You would have these lone pairs on the outside, and then you would have a carbon-hydrogen sigma bond over on the left-hand side. So in essence, that's how we draw the orbital picture for any molecule that we would have, and there's more example problems in that folder in that assignment.